This video is going to talk through the third question from the review exercises for the end of the semester. Suppose that resting heart rates of healthy adult men are normally distributed with a mean of 70 beats per minute and a variance of 49 beats per minute. So here's our distribution. Part A asks what percentage of healthy adult men have resting heart rates less than 50 beats per minute. So this is our question in Part A. So I can either use the normal CDF with my calculator if I have it, with a mean of 70 or standard deviation of 7 because the variance is 49, or I can standardize. So this is the probability that a standard normal takes a value less than 50 minus 70 over 7, which is the probability that a standard normal takes a value less than negative 2.86, which is approximately 0.0021. Okay. So now, question B says, if 12 healthy men were randomly selected, what is the probability that less than 3 of them have resting heart rates less than 50 beats per minute? So here I've got a random sample, so they should be independent. If I'm randomly sampling from the population, there's an equal probability each time that my selected man is going to have a heart rate less than 50, and I've got this probability of that happening. I just found that out. So Y, the number of the 12 men with heart rates less than 50, is going to have a binomial distribution. Our fixed number of trials is our sample size 12, and our probability of finding that each of those men has a heart rate less than 50 is 0.0021. And so we have this probability mass function, f of y equals 12 choose y times 0.0021 to the y power times 1 minus 0.0021 to the 12 minus y power. And y can take values from 0 up to 12. So now I want to find, as I say, for part B, the probability that less than 3 of them, so y is less than 3, have heart rates. So I can find this by evaluating this function for 0, 1, and 2. Those are the values less than 3. And if I do that and go through and do all my math, I'm going to come out with a probability of 0.999988. Now if I want to find the probability that exactly 3 of them have a resting heart rate less than 50, so I'm looking for the probability that y is equal to 3. Then I'm going to take my probability mass function and evaluate it at 3. That's going to give me 0.234, 1, 2, 3, 4, 5, 0, and 2. If I go through and do my calculation, Part D says if 12 healthy men are randomly selected, what is the expected number that will have resting heart rates less than 50 beats per minute? So D, the expected value of y, binomial, remember, is n times p. So this is going to be 12 times 0.0021, which gives me 0.0252. And then the last part here, E, asks if 12 healthy men are randomly selected, what is the probability that the mean heart rate is less than 65? So since we're sampling from a normal distribution, the distribution of the sample mean will be approximately normal. The mean of that distribution, sorry, I should be looking at y bar really, right? X was individual. Y is let me just see. 12 healthy men are heart rate. Oh, no. X bar is good. Looking at a mean among individuals. Okay. So I know that the distribution in the population, it has a mean of 70, so the mean of my sample mean will also be 70. And my variance in the population is 49, which means my variance of my sampling distribution is 49 divided by my sample size of 12. So now, the probability that the sample mean is less than 65 is going to be the probability that a standard normal is less than the standardized value, 65 minus 70, divided by the square root of 49 over 12. That's the probability that a standard normal takes a value less than negative 2.474, which is approximately 0.0066. So there's question 3. Let me know if you have any questions. Thanks.